Okay, let's do some multiplying and dividing fraction story problems. Okay, so I got one pre-canned for us here. They said find the total length of 12 pieces of wire, each 9 3/16 of an inch long. Now for these story problems, I'm just going to have you do the plan, calculate, and review steps. The prediction step, that'll come back into play in later sections, but we're not gonna focus on it here. Okay, so now we look at this one. Total is the key word I would say in here. Total either implies multiplication or addition. It's more commonly associated with addition, but in this case total. And then we got 12 pieces of wire, each 9 3/16 inches long. So they want us to find the total length overall. Okay, so now since each piece of wire is the same length, or we have to add this up, however many pieces we have, because think about it, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Though just imagine those are symmetrical. I could add up 9 3/16 12 times. That'd be my total length. This is what's going on in the physical world. But I would rather use arithmetic and get my answer a little bit more efficiently. Okay, so for the calculate step, or the plan step, I'm going to take this times this. So for my plan, let's go to pen. So for the plan, I'm going to do 12 times 9 3/16. Now, when you're doing this on Canvas, you can express this however you want. If you want to type that out, that's fine. Refer to the earlier video on how to use the equation editor. It's up to you how you want to attack this. I don't have a preference. If you want to type that on words, it's up to you. Okay, so now let's do the calculate step. Okay, so now we take 12 times 9 3/16. Okay. Now, when I'm doing this in my mind, I kind of do 12 times 9 as a precursor, so I kind of have an idea if my arithmetic goes awry where it should be. So I just do 12 times 9, which I think is 108. Okay, so my answer should be somewhere around 108. It's going to be a little bit more because of the 3/16 part, but that should be the ballpark answer. Okay, so let's use our newfound drill problem skills to make this 12 over 1. And I'd really encourage you to pause the video at this point and try to do this on your own. Okay, so let's see, 9 times 16 plus 3. 9 times 16, I think that's 144. I'm going to use my calculator here to check that. Let's see, 9 times 16, 144. My basic arithmetic skills are still amazing. Sorry, I don't mean to be braggy. Let's see, so then we do 144 plus 3, so that's 147 over 16. And if you remember from the video from changing mixed numbers and improper fractions, if you recall me saying this is something you use a lot, yeah, it's something you use a lot. Okay, now we look right here. Now we want to reduce, because I don't want to do 12 times 147. So 12 times 16, those can be reduced by, 4 goes into both of those. So this gets knocked down to 3. And this gets knocked down to 4. Now, it'd be nice if we can get rid of the whole 16, but it just doesn't work out that way. Let's see, so we divide here, we multiply straight across. What's left over? I'll do the 1 times 4 first, because that's easy. 1 times 4 is 4. And 3 times 147, I'm going to cheat again. Use the calculator. 3 times 147. That gives me 441. Really, really big number. Okay, now depending on what calculator you have, you might be able to just plug this fraction in and get your mixed number answer. But if you have a normal calculator like me on my computer here, I'll show you a way you can kind of cheat a little bit. So if I do 441 and I divide that by 4, because remember the fraction bar here just really means division. So we do that. See, I get 110. I get 110.25. Which is pretty easy to change to a fraction because you think 25, I think 25 cents a quarter or 1/4. But with that, you can kind of cheat a little bit and you can get your whole number. So then you think, okay, 110 times 4 is 440. So that gives me a remainder of 1. So 10 and 1/4. Okay, and then we had our estimate for this one. I said, it was about 109. or 108. Okay, so then we got 110 and 1/4, so we're probably in the ballpark for our answer there. Now, the good thing about multiplying and dividing, or multiplying fractions, is that order never matters in multiplication. Okay, you can flip-flop these numbers all day long, and you'll get the same thing no matter what. Okay, whether I do 9 and 3/16 times 12, or the way I did it right here, you'll get the same answer. Just think of think of a simpler thing, really quick to multiply. Like if I do 2 times 3, it gives me 6, or 3 times 2, that also gives me 6. Okay, now the reason I'm telling you this information is for the next problem, which I have down here. So we look at this one, we have a division problem down here. Okay, now a key word or key indicator that you know this is division is this word, this phrase right here. How many? Okay, how many is like 90% of the time indicates division. Sometimes they can sneak it in and give you a multiplication problem, but most of the time it'll be division. So let's finish reading the problems. They said, how many lengths of pipe 2 5/8 of an inch can be cut from a pipe? Oops, that shouldn't be feet. That should be inches. I did not proofread my problem because obviously we can't divide inches into feet. Okay, so let's see, how many lengths of pipe 2 5/8 of an inch can be cut from a pipe 21 inches long? Okay, so I mean, I really like these problems too. Like anytime you see the word cut, that's an indicator of division, because when you cut, you divide things, right? Now be careful with this one, because what a lot of people like to do is they'll put the numbers down in the order the problem gives them. So they'll do 2 5/8 divided by 21, and they think, okay, well, that's the order the problem gave it to me. I might as well just put in that order. I did it earlier in the multiplication problems and nothing happened. Well, that's because, like I was saying earlier, multiplication order doesn't matter. So the correct order for this one, again, just like I always do, probably sick of me doing this, but I don't care. This is wrong. Okay, the right way is 21 divided by 2 5/8. Because we're trying to figure out how many of these are in this. Okay, so, and it won't always be a guarantee the bigger number will be on the left side. It depends what they are, but just make sure to read the problem really carefully. We're cutting them up into these sections, so this has to go first. And with this one, if you do it this way, I'm gonna work the arithmetic here to show you why this doesn't make sense. If you work it this way, the answer you get won't make sense. I mean, think of the estimate part for this. Okay. I would say you could probably get about 8 of these out of here, because I think 8 times 2 is 16, because 5/8 is a little bit over half, but 8 times 2 is 16, that's still under 21, so you could probably at least get 8 lengths of pipe. You can at least get one, right? Because if you have 21 inches of material and one of them's only 2 5/8 of an inch, you can at least get one, because you have enough material to make that, I guess, unless you're really terrible at cutting things. But okay, let's do the arithmetic here. So we have to make this an improper fraction first. Let's see, so 2 times 8 is 16, plus 5 is 21 over 8. We put this over 1, and then we flip it. Let's see, so and then we change this to times. That'll give me 1 over 21. You should notice here, these 21s can cross each other out, so you get 1, or they can both be reduced by 21. Multiply by what's left over. 1 times 1 is 1. 8 times 1 is 8. Okay, so we look at this one. On the wrong side of things, let me draw a line down here. The wrong side of things, we got 1/8. That doesn't make sense, because if I have, like I was saying, 21 inches, and each one is 2 5/8 an inch long, and you can't even get one whole one? No, okay? So you probably got your order mixed up. So when you're doing these, really ask yourself, is your answer reasonable? Does it make sense? So let's do this the correct way. Let's see, so this is the correct way. So let's see, we write this as 21 over 1 divided by, make this a mixed number, which we should already know the answer. That's 21 over 8. Then we flip the second fraction. So we get 21 over 1 times 8 over 21. Then these cancel out, just like they did in the last example. multiply by what's left over, and write it over here. So we get 8 over 1, which is just 8. Which seems like a feasible answer because when you look at this one, when you look at this makes sense. You know, it went with my estimate here. You know, like an 8 makes sense. 1/8 does not make sense. That's kind of a ridiculous answer. It's like we can at least get 1 out of that. So when you're doing these problems, especially on Canvas, make sure you're really asking yourself, does my answer make sense? Does it fit the context of the problem? And like you'll hear me say multiple times, do not just get an answer to get an answer. Really think about what you're doing, what you're supposed to get. Does it make sense? Because this helps you troubleshoot things so you can kind of weed out ridiculous answers.